Right. Your first video of semester 2, and your first one of electrostatics, electricity and magnetism. Remember, we're moving to chapter 22. Like I said, there'll be less chapters this quarter, but they will cover actually less material. We'll just cover it in a little bit more depth. And again, those of you friends with math, you're going to really enjoy this particular unit. But this is the very basic idea of it, and we're going to talk about charge and electric flux. So what we mean by that is, again, we've looked at first we have to talk about electric field. We know what the field looks like for a positive test charge. Well, that arrow didn't work out so well. And we know for a negative test charge. But what about if we don't know? Like, we just have a bunch of lines. In this case, if I just gave you the lines, you could pretty much tell that there's going to be some sort of positive charge here in the center. And that makes sense. Okay. All right, so, I mean, we can do that. But there's actually a more interesting way to do that, and a way that will work better for all kinds of shapes. The way to do it is to consider the idea of having a box with an unknown amount of charge in it. Like, say, a box that looks like this. Now, this box is a closed surface. In other words, you can't leave the space inside this box without crossing one of these sides. In this case, it has a surface area. Which is what, 6 times the length of one side squared, because L squared is going to be one side, and then you have 6 sides, including the top and bottom in this. And let's say that I have let's say I have a charge inside there. Well, the arrows would look like the electric field lines, I should say. The arrows that represent them, the vectors, would be equally spread in all directions. They'd be like out this way, and up there, and out there, and there. And there'd be some that came out of the page, some that went into the page. They would come out in every single direction. And that seems pretty reasonable. Which means that if we looked, 1/6 of the entire electric field, I'm not answering that, people, is going to come out of each side. Which makes sense. Now, let's say that I showed you the box, but I made the arrows go into it. And I made the same number that I made before. One that goes that way, one that goes out that way. Oops, sorry. No, they went in. Sorry. In. Okay. In this case, you would say that inside here, there would probably be a negative Q. The same size, let's call this positive Q. The same size as the one above. But how about if I double the number of lines? Let's say that I had Okay, let me finish the box. Like I double the number of lines so that I have, instead I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, you would say, well, I know that the charge is coming out, so I know it's positive. But I know it has twice as many lines, so I can make a pretty good guess about the amount of charge that went in there. That would be 2Q. And that seems pretty reasonable. Now, the last example I want to look at before we kind of generalize about this charges and field lines thing inside a closed surface is, let's say that we had our same box. Kind of roundy, that one. Okay. And this time we have same number of, we have some lines coming out, and then we also have some lines coming in to all the same sides. So that goes in this side and that side. Okay, good. So I've got the same number of lines. Now I can't tell. Now that means I must have some positive stuff and some negative stuff inside there. So I must have positive Q and I must have negative Q. They're in there somewhere. I can't tell where they are, but I know in this surface that the total charge has to be 0 because I have more of them. Or I have equal amounts of positive and negative field lines going in the box and out of the box. So let's do a quick summary of field lines in a closed surface. Into is positive, or sorry, out of is positive, into is negative, more equals more charge, net lines equals net charge. So if you have positive and negative, you have to take subtract positive and negative ones. That makes sense so far? Yeah, like you're gonna answer. Good. I'll stop there and we'll do our second video, which will be just the concept of electric flux.